Hello all. In this session, we are going to discuss about exception handling in Python. So before we jump onto the topic, let's discuss something about errors in Python. What all errors we encounter usually, right? What all errors we have been looking at. The very first thing you might have experienced is something called syntax error. Okay, so what is syntax error? Syntax error is the error which the interpreter throws to us when you do something wrong and something not following with the rules and regulations by this programming language. Okay, for example, if your programming language says that you can add some number to other number, and if you don't provide the other number, so the operator plus is used to add two numbers, right? If you don't give the other number, so it is not, you are not doing something legitimate step here, right? So you are not doing something as per the rules of the programming language. Okay, so such a thing is interpreter shows us that you are doing something wrong, and we learn how to manage the syntax, how to make sure the syntactically you are writing the correct statement. Okay, so this is a simple example of a syntax error. We have been looking at those errors. I hope you guys have experienced and now much confident on how to manage your syntax errors. So how to make sure that you are writing a program as per the rules or as per the programming constructs which is defined. Okay, the other type of error is runtime error. So in the runtime we find some errors. Okay, and those are something we need to handle, and we are going to discuss more about that. For example, okay, if I do 4 plus 6, that's absolutely a good thing, right? Syntactically there is correct thing, and neither that shows any error on the runtime. Okay, but let's imagine I use some number something here, right? So something like this. If I do want to try and convert a numeric number using int, that works. But if you do provide a string, but that string is not a numeric string, then it gives you an error at the runtime, because syntactically integer function, if you look at integer function, accept x, and x has to be a string, but this string should have only the numbers, right? But that user may not understand and try to do something, and it gets the runtime error. Okay, syntactically we are doing good. Okay, and another error is, let's say 182 and divide by 0 you try. This is another error, right? So it's division by 0. This syntactically there is no problem, because we are using division operator, and we know that two numbers can be divided, and 0 is the one which I am using to divide 182. Okay, so this might occur accidentally. Somebody may not be purposely doing it, but for example, suppose you get a number, let's say int, and take the input from the user, enter a number, and now print num divided by, or let's say 187 divided by num. Okay, so this is what a simple statement. You might find it in your program somewhere, and user press 7, gives input as a 7, or you may be reading this input from some file or somewhere, right? And you are now trying to divide this number. Ideally we never expect this number to be 0, but by any chance, by mistake, if you get that number as 0, so it is not going to do the proper execution, right? So it stops your program completely, and it throws an exception. Okay, for example, if I write another statement, end of code, okay, and here if I do 0, my end of code or the further code is not going to execute. Okay, that might cause a problem. Okay, so sometimes we have to handle these exceptions which we get at the runtime, and those exceptions are called runtime exceptions. This is what we are going to look at now. Okay, and why we need to handle is because if we don't handle that, the program gets abruptly terminated at the moment you find this exception at the runtime. Okay, so other category is something called logical errors. What I mean is, the logical error means, for example, you have a billion. Okay, the number is billion, and suppose you want to subtract or maybe you have subtracted, let's say 100 out of this, or 108 or something you want to subtract, but while doing that, okay, instead of 1 billion, suppose you forget 10. Okay, so you just forget, suppose 10, and make such calculations, and then you realize that right, so the outcome which is which you are getting, you may not realize at this moment, but if somebody complains, you realize that okay, this is something wrong, right? This decision, this calculation is wrong, because if I subtract 108 from 1 billion, okay, so it cannot be 99.9999892 million, right? So this is something wrong, isn't it? So it has to be more, actually it has to be 999 dot something million, right? So that is something, that is a human error. Usually this happens in your big programs. If you have a huge code and if you don't follow some coding guidelines, so you may encounter such issues. Okay, so those are called logical errors. So there is a logically something went wrong in the code, which you may not be able to figure out syntactically, which may not be triggered by the interpreter and say that it is a runtime error, but it might be something which the developer has to find out what is going wrong. Okay, just imagine you have $100,000 in your account, and if you withdraw $1, so it should not be the wrong calculations happening, right? And if you see that if your total balance is not the correct, that means some calculations are gone wrong. Okay, so those logical errors, that may not, system may not throw an error, or neither it is a syntax error or it is runtime error, but your total calculations goes wrong, right? The moment you see those calculations, you probably complain to the bank, and the bank people will check the system, and the developer might see that okay, something went wrong on your specific case, and that probably causes the issue, and that's where we have to fix. So there is something called debugging techniques we have to use. There are various debuggers available in Python, like any other programming language. We have debuggers for Java, C++, .NET. Similarly, we have debuggers for Python. So we can use any IDEs like Spider or PyCharm. So there are built-in debuggers which we can use. You can break we can break the flow, we can put some breakpoints, you can track the entire step-by-step execution, and that's where you could figure out. Okay, PDB is another module which works as a debugger. So we are not going to discuss a lot about logical errors too here. So we are now going to see what runtime error means and why we need to handle those. Okay, a simple example: suppose you are getting a number, this was unexpected, but suddenly something happened and your entire program is now shut down. Okay, you can't do anything. So just imagine that you go to a ATM and to withdraw a cash, and you put your card and you try to insert the pin number, and if you enter a wrong pin number, how about machine going down, right? So machine or the software in ATM goes down, it won't come up, it doesn't start at all, right? That's not a good situation, right? So that is the exception, that is what the user has done something wrong. So system should handle at runtime. So at runtime, user has given a wrong pin. Okay, so that should not cause the entire software to stop, but it should handle that kind of error. The same is the case. I will take one example here, right? For example, I will use the same statement here in this example. Suppose I read a number, okay, and then I let's say calculate num plus let's say 25. Then I will take a choice from the user. Let's say if you want to continue further, input, enter your choice. Okay, yes or no. I'm just saying, in fact you want to use this number, or you don't want to use this number. Okay, if choice is equal to yes, then we do something. Maybe I will do z plus 2 and print it. Okay, else I want to make sure that I don't use z here. Instead I will simply say that print this case needs to be handled differently. Okay, so here you could get x equal to 8 and then print x minus 1 or something. I mean, I'm just writing some code, right? It doesn't make any sense, but I want to make an important point here out of this program. Just imagine this is a program of around 8-9 lines of code. Okay, at the moment you give a number, let's say you give 6. Okay, you gave 6, that's fine. Now you give a choice, right, whether you want to use this number or not somehow, right? Enter your choice, yes or no. Suppose I say yes and it prints 33, and that's what exactly I wanted. Okay, just imagine I run once again and this time I give high, but this time the next option I wanted to give was n. Okay, but it never allowed me to even it didn't even ask me whether what is your choice, whether you want to use this number in NUM or not, right? It has not asked. In fact, I was not bothering about what the user has provided. I wanted to use the second case. Okay, I repeat, I will write this a little differently now. Let me say let's say enter okay, do you want to use num? Okay, yes or no. So actually I don't want to use this number, right? Let's say, okay, for now I will make it simple. Let's say I type yes and it is done. So I will just change this sequence here. So suppose I give a number 8 and then it says yes. Okay, that's fine. The second thing is, suppose I say hi, and the moment I do that, it's all gone, right? So this particular number is now, that number has given me the error, that is the runtime exception, and because of that my entire program stopped abruptly. Okay, yeah, I agree, this is the wrong input, but this should not crash or stop my entire program. It is not crashing, crash is the wrong word, but yes, it should not stop the whole program here. Okay, yes, if it is a wrong number, or maybe I should have some validation, I should have some kind of handling to that number, but sometimes this number may not be relevant because I wanted to do some other task here. Okay, so in that scenario we have to handle those exceptions, right? So that's why we can write some code here. There are a couple of important keywords we are going to discuss is try and except. Okay, these are it's not capital, it is small t, and e is also small, except is small e except. Okay, so try and except is primarily an exception catch blocks in Python, okay, which is used to handle the runtime exceptions which you may encounter. Okay, there is a list of standard exceptions, let's say exceptions in Python 3. Okay, just for your reference, I will just open this. There are some Python inside a Python documentation you will find some standard exceptions. Okay, just a moment. Yeah, I think this one. Okay, there are some built-in exceptions we should know, we should be aware of. For example, we have just seen that zero division error, or some kind of exception. We have seen value error. Okay, if you look at this, there is somewhere a value error as well, right? So these are some of the exceptions, the standard exceptions so the Python will raise. Okay, and all these errors or exceptions are derived from a base class called exception. So we will discuss this in detail when we discuss about object oriented programming. So these are some of the standard exceptions which maybe you may encounter. So what you can do is you can put a block of statements where you suspect that something might go wrong. Okay, so in that case you could handle this and say that there is some value error you have to handle. Except this, as you can just create one alias here and print what exactly the error. Okay, exception occurred, and what is that exception you can write here. Okay, and then you decide what to do. Let's try here, right? So number, I give high and it suddenly says that, oh, there is an exception, right? So exception occurred, and the moment it has thrown here, so it is all done. So let me take these two things out here. Okay, so my point here is I will probably use that later on. Okay, let me see, if I give this, it says that exception occurred, invalid literal for integer with base 10 high, right? So this kind of things have happened, right? High because this high is something you gave as a input, right? So you see here you see that it is asking, so the next statement is getting executed, choice, and I don't want to use it. Okay, and then at least I get a chance to understand these things completely, right? So here the program has not stopped abruptly. Okay, so another example is let's say I will use this number, and instead of the addition, I will use the subdivision here. Okay, so same thing, there is no difference. This time I give right number. Do you want to use no? And this was all good, right? And now this time, instead of high, if I give high, it says this is handled somehow, and if I say no, this is also good, no problem. Okay, but now again if I do and give 0, okay, so this time it says that it is giving me another type of exception. Okay, but unfortunately we didn't handle this type of exception, right? So there is a provision to handle another type of exception like this. Okay, and I can see that 0 division error has occurred. Okay, another exception has occurred. Okay, I just write this. So this time if I do 0 division error, and if I say no, that's okay. So this is how we can, at the runtime, we decide and we handle those exceptions, so that these exceptions are not going to terminate your entire program. Okay, so the abrupt stop of the program can be avoided with the help of handling this. Moreover, this is the good practice to handle your exceptions, because if you have a huge code, it is quite difficult to debug and understand what is going wrong in case if something goes wrong. Okay, so the overall process becomes simple. Overall handling of your software or managing your software becomes simple. So we have these exceptions, and you could give different tries, and you understand how you can handle those exceptions. Okay, this is a simple exercise, but yes, precisely I'm trying to explain how to use try and except. And if you see except, so you can be specific with one exception, but there might be one question that I knew value error, so I tried to handle. I didn't know about the 0 division error, so how to make sure you understand all different types of. Now there might be a third type of exception. So how many lines of code, or how many times I should have except block? Okay, the one thing is clear: one try can have 2 or multiple 1 or 2 or 3 or any number of except blocks. That's fine, but why one will write, or how we will see that what could happen, right? So if I know that these many things could happen, I can have validations, right? So yes, we can have validations, but 100 validation doesn't make sense, right? And neither 100 except doesn't make any sense. So in that case, there is also a possibility to use a generic exception. Okay, so this is the generic exception. If you find value error, it comes here. If you find 0 division error, if it comes here. If it comes with any other error which you even don't know, right, what happened, so you can probably check here and print that some kind of generic exception has occurred. Okay, and you can check this with the help of E, or you can write anything. Okay, that doesn't matter. I'm just trying to make some kind of alias for that. Okay, suppose I do give as a list here. So it says again it's a value error, and unfortunately we got a value error and we can't do anything. So just imagine that we don't have this now. Okay, and now it somehow it happens to be a 0 division error, and this time 0 division error is handled properly. Now next time I don't give 0 division error, but I give HH, and this time it is given the exception as a generic exception, because now this time it won't give you the program gets stopped, right? This won't happen this time. The reason is the exception is handled even if you don't have that value exception by default. So the every exception will be handled by the exception. Okay, even if you don't have zero division here, okay, I write it in other cell, probably that will be good. So even if you don't have zero division error, so this generic exception will be handled automatically. Just let me restart this because this was already running here, and now I run this here. Okay, so here suppose I put 0, it still says that okay, generic exception it has handled. Somehow this statement handles every exception. Okay, but more specific is always better. You can be specific here. You can say that okay, except zero division error, because you are expecting a zero division error and you are handling that zero division error properly. Okay, you can perhaps give the user a chance to give a non-zero number, right? So maybe here, for example, okay, you can probably say that number enter a non-zero number. Okay, so this makes little more sense than just having it the simple message. Here if user has sorry, the last cell is still running. Okay, let me run now. Okay, this time, oops, why? Yeah, it's running now. Okay, this time suppose if I give 0, now this says that enter a non-zero number, right? Let's say user now has taken care that he has entered 7 and your program gets executed, right? So this is the way to control, way to manage your exceptions at the runtime. If you face any challenge, if any such unexpected thing happens, unexpected data is entered by the user or unexpected data is received by, from some sources, and your program may get terminated abruptly. So to avoid that, we need to handle exceptions at the runtime. Okay, we have try except block, so which you can use. We can put a block of code where you suspect that something might go wrong. So those things are, there is no rule to only keep 1 line, 2 lines or 4 lines or 10 lines inside a try block. You can put the entire code into try block, that's okay, or you may put relevant code, the small piece of code, so that makes more sense. So better you should have more try and except blocks, that way it is easy to debug your overall program. Okay, so this is how we can do. Now here you may think like here what if user again enters a 0 value, right? So here then if user enters, let's try what happens, right? Let's say user has entered 0 and now program has raised an exception, and the exception is raised and now it is coming under this particular block. Okay, here it is, now we are telling that okay, enter a non-zero number, but user, we don't have control over the customers, right? They might do anything. So now if it says we put 0 again, so it is still saying the zero division error. So what is the point? And it has stopped because I was more interested in this piece of code, right? This piece of code, at least it should have allowed me to work, because this is independent of what number is given by the user. Okay, but unfortunately your program stopped, and we need to handle this as well, right? So we can do one more try except block here, and we write here exception and print oops, another exception occurred, please. Okay, we can think about what to do. Okay, proceeding further program. Okay, it might be risky, definitely nobody wants to proceed with this kind of exception, but at least you got to know that okay, this has some exception occurred, and you should proceed okay, I would say that proceed without using z value. Okay, so maybe that is kind of an indication we give. So user should at least make sure that this time the user should not use the num value here, num or here z, that's okay. Okay, so this is just a sample example I was trying to explain you. The point I want to make here is try except can be nested. You can have a try within a try block, or you can have a try within an except block. So you can have any number of tries, try blocks within the other try blocks. That means the try block can be nested. Okay, and another important point which we already spoke is one try should have at least one except, but one try can have many except. Okay, and the other obvious thing is we cannot have two try and one except. So definitely that's not possible. If you are putting some try block, so suppose you are putting 2 or 3 try blocks, just one except won't suffice that, right? So you have to have try and then one except at least. So try and accept is together is complete thing, and try and multiple accept is good thing, and it is acceptable, and try and accept can be nested as well. Okay, the important point, but yes, very useful in your program. You should see try except blocks, and if not, then even if you have a right basics in place, you should always use try except blocks. Okay, so now let me also explain you, there is something called raise keyword. Okay, so raise keyword is used if you want to explicitly raise some exceptions. Okay, so for example, I will take, let's say, num int and input. I want to take enter your age. Okay, and you got the age. Okay, now what you are doing is you are actually opening a registration page. Okay, registration page, registration started. Okay, let's say. Okay, I'm just doing some kind of a small things here, but I want to make sure that the user has entered his or her age, and now we are just manipulating that. Okay, let's say number plus 8 and 87 or something we are doing. Okay, and user has entered, let's say 27, and it has done its work. But the moment user raise enter the age, and now we know that this particular registration is supposed not for the kids or the teenagers or whoever is having age less than 18, they should not register, because this registration may need let's say a PAN card in India. So that gives me the PAN card is allowed, or any kind of such registration is allowed for only those who pay the taxes probably. Okay, so or who are eligible to make to earn, right? So in that case, I don't want to really consider those ages whose if somebody is putting less than 18 years. Okay, but we can't say this is wrong. This is logically nothing wrong, syntactically nothing wrong, and even at runtime that is nothing wrong. Okay, in that case we should have the validation. Okay, if num is less than 18, okay, we have to print invalid age group, let's say. Okay, we could have something like this, right? But how many such validations I keep on putting, right? So that is not a good idea. That's what I said, right? Initially also we can validate here, we can have some validations, but the better way to handle is you can probably work with some kind of exceptions here. Suppose here that if range is less, then you can explicitly raise and say that there is a value error. Okay, what is the exception for value error? What is the name of the exception? Yeah, that's right, value error. Okay, so you are now explicitly saying that. Okay, so and you know very well that this is not a wrong age user has tried has put into. Okay, but still there is a provision to raise this, and we can accept that as E and print this registration is allowed only for adults, let's say. correct? So that's what the message we can give, and we can perhaps give some other services. Okay, maybe I will write here another function only uh, for kids. Okay, and I will write some other function somewhere up here, define only for kids. Welcome to kids zone. Print, do you want to play game? Okay, in fact I can do this choice equal to input. Okay, yeah, I'm just trying to make you some kind of the different program here to just make sure that thanks for playing. That's it. I'm just trying to do something. Suppose it is 8 years, so this registration is allowed only for adults, but now I can make sure that okay, we can take and go with the play area this time here, right, the kids area. So maybe, do you want to play the game? Yes or no, doesn't matter, right? I just give one yes, and then thanks for playing, and then it says registration started and this other things, right? But obviously we can restrict that. The point I wanted to make here is, the moment you get such specific number, you may also raise exceptions by explicitly, right, by yourself. So otherwise, so far we have seen it is exceptions are generated automatically. We are not doing anything, it is automatically generating such exceptions, but sometimes we may want to raise our exceptions explicitly, right? So this is the implicit generation, right? The moment I type something else, so I don't have to say anything, it automatically generates that kind of exception. But here the value error, this is actually not a value error, but for this particular program this could be a value error. Means the expected value should not be less than 18. That's what the condition you should have, right? So you can validate that in a different way, but the point I want to make here is you can raise the exception as well explicitly, right, and mention that okay, this is what the value you got, and you can have some kind of a piece of code there as well, and you can handle those kind of customers or those kind of data. You can check, you can decide on what flow you want to use. Okay, so that's where a raise keyword can be used. A raise is used to explicitly raise an exception, and otherwise there's an implicit exception it raises, and automatically it raises when there is any syntax or any type of error at the runtime, be it a zero division error or a value error. So those errors gets generated automatically. I mean, those errors are generated, then the exceptions are automatically raised. But explicit raising is what we can do using raise keyword. Okay, I hope you understand. This is the basics on exception handling, and very useful concept. And let's use some time when we want to explore more about some of the bigger programs, and we try to add some exceptions there. Thank you for watching. See you in the next talk.